Alright, here's the second part for the mock final, you guys. Now, here's number 33. So, remember, when you guys do this problem, right, you guys have to take these types of proportions. So it'd be A over B is equal to C over D. Now, the only problem is we need to find what our B and C value are. So recall, right, the whole minus the part will give you the other piece. So 14 minus 6, you guys, it's 8. So that section is 8. For this side, it's 21, the whole minus the part. So this one is 21 minus 2x. And this will help us because if we use our proportional ratio, we get 6 over 8 is going to be equal to 21 minus 2x all over 2x. And then from there, you guys just cross multiply. So 6 times 2x is 12x, which is equal to 8 times 21 minus 2x. Distribute to both. So we're going to get 12x is equal to 8 times 21 is 168 minus 8 times negative 2x, negative 16x. Let's add 16x to both sides. So we get the variables on one side. So 28x is equal to 168. Divide both sides by 28, and we are going to get that is gonna be, let me get this out, I think it's 6. Yep, 6. So your guys' x value is going to be 6. Okay, this one, so remember to get this, you gotta do the whole minus the part. So 5 minus 3, you guys, is 2. And then we can just set this up, right? Set up this proportion. So we're gonna get a over b, which is 2 over 3, is equal to 2x minus 6 all over 6. Cross multiply, 6 times 2 is 12, equals 3 times 2x minus 6. Distribute, 12 is equal to 6x minus 18. I'm just going to add both sides by 18 so we get the constants and variables to be on different sides. Divide both sides by 6. 5 is going to equal to x, so the answer is going to be D. Alright, so now we're at our trig. So if you guys recall, SOHCAHTOA, right? So remember, sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Okay, so when you guys take a look at 35, you gotta find your thetas right there at angle Z. So I'm just gonna mark everything down: opposite, adjacent, and hypotenuse. So to find the tangent of theta for that problem, tan theta is going to equal opposite over adjacent, which is 40 over 30. Simplify, so divide top and bottom by 10, so you're going to get 4 over 3. So your guys' answer is A. Let's take a look at this one. Okay, so cosine of A would be theta's right there. So let's just mark everything right. Opposite, adjacent, hypotenuse. So cosine of theta is adjacent over hypotenuse. So 21 over 35. Divide top and bottom by 7, and you guys are going to get 3 over 5. So 3/5 is going to be C. 37, I'm just going to drag this, you guys, so you guys can still see the SOHCAHTOA piece. Alright, sine of Z, which is this angle, right? So opposite of that angle, opposite, adjacent, hypotenuse. So for sine theta, we are going to have opposite over hypotenuse, so 9 over 41. A. And then for this one, tan x is this one. So opposite to that is here, adjacent and hypotenuse. So remember, tangent uses TOA, opposite and adjacent. So tan of theta, or x, is equal to 8 over 15. So you guys are gonna have to know, be very good at using your guys' ratios, okay? All right, I'll still continue to drag this along because a lot of this stuff we are using for... All right, so for 39, so it says we gotta find this angle measurement, okay? We need to solve for the angle. So hypotenuse, opposite, adjacent. So since there's information at O and A, that means we're going to be using tangent. So tan theta is equal to 37 over 25. Now remember, to solve for theta, we need to get rid of the tangent part. So we got to take the tan inverse of both sides. So these cancel, so theta is equal to tan inverse of 37 over 25. And on your guys' calculator, it says angle to the nearest degree. So remember in your guys' calculator, make sure you guys are in degrees, okay? Make sure you guys are in degrees. I'll check everyone's calculator tomorrow just to make sure. Or not tomorrow, but on finals day. Alright, so tan inverse of 37 over 25, it looks to be 56 degrees about, so that's B. Okay, let's take a look at 40. So here's theta, right? Now let's just label everything with hypotenuses, opposite, adjacent. There is information at the A and the O, so the only trig identity that uses opposite and adjacent is tangent. So another tangent, theta, is equal to opposite, which is 3, over adjacent, which is 3. So that's just 1. So remember, to isolate our theta, we have to take tan inverse of both sides. So we really have theta is equal to tan inverse of 1. And theta is roughly 45 degrees, which is B. Alright, this one, here's theta. Label everything. Hypotenuse, opposite, adjacent. Where is there information? At the O and the H, so we're going to be using sine. So sine of theta is equal to opposite over hypotenuse. Let's take the sine inverse of both sides so we can isolate the theta. These cancel, so theta is equal to the sine inverse of 8 over 19. Put that in your guys' calculator, and you guys should get around 25 degrees, because you guys gotta round it to the nearest degree. degree. Okay, last one for this set of problems. Theta. Label everything opposite, hypotenuse, adjacent. There is information at A and H, so adjacent and hypotenuse, so that's cosine theta is equal to adjacent over hypotenuse, 38 over 43. Now, to isolate our theta, we gotta take the cosine inverse of both sides. So theta is equal to cosine inverse of 38 over 43. Theta is roughly around, so put in your calculator, cosine inverse of 38 over 43. So round it to the nearest whole degree, should be 28 degrees B. Okay, so still gonna drag this along, you guys. Okay, 43. Now we have to find the side length. So, in the perspective of this angle, right? So opposite, adjacent, hypotenuse. Well, the x is at the A and the 18 is at the H. So the one that uses A and H looks to be cosine. So cosine of 27 is equal to adjacent x all over hypotenuse 18. So to solve for this, you guys gotta cross multiply. So x times 1, you guys, is just x equals 18 cosine 27. Punch this into your guys' calculator, and it says round to the nearest 10th. So once you guys put 18 cosine 27 in your calculator, round to the nearest 10th, it's going to be 16.0. So that's going to be D. 44. In the perspective of this angle, right? So we got opposite, adjacent, hypotenuse. It looks to be, we're using A and H again, so cosine of 51 is equal to adjacent over hypotenuse, so 20 over x, all over 1. Cross multiply, so x cosine of 51 is equal to 20. Now to isolate this x, we gotta divide both sides by cosine of 51. Cancels, x is equal to 20 over cosine of 51. So x is roughly around, so put 20 divided by cosine of 51 in your guys' calculator. You should get around 31.8, which is C. Okay, 45. In the perspective of this angle, so opposite, hypotenuse, and adjacent, there's information at the O and the H, so we're going to be using sine. So sine of 47 is equal to opposite over hypotenuse, so 11 over x. All over 1, so cross multiply, so x times sine 47 is x sine 47, which is equal to 11. Divide both sides by sine 47 so we can isolate our x. X is equal to 11 over sine 47. So x is roughly, round it to the nearest 10th, 15.0. So you guys should have gotten A. And lastly, 46. In the perspective of this angle, right? Opposite, adjacent, hypotenuse. So there's information at H and the O, so that means we're going to be using sine. So sine of 22 is equal to opposite over hypotenuse. Let's cross multiply. X sine 22 is equal to 13. Divide both sides by sine of 22. So x is equal to 13 sine 22. Put that into your guys' calculator, and you should have gotten 13 divided by sine of 22. 34.7, which is C. So that's essentially all of our trig type stuff. Okay? Alright, 47. Find the measure of the arc or central angle indicated. Assume that the lines which appear to be diameters are actual diameters. So, remember, central angle and the arcs are the same measurement. So this is also 100 degrees. So they're telling us to find this angle, HFI. So basically we have to just find this arc. And then the central angle just equals the arc. So you guys know for a whole entire circle, it's equal to 360 degrees. So 145 plus 100 plus x is equal to 360. 245 plus x is equal to 360. Subtract 245 from both sides so we can solve for x. X is going to equal to 115 degrees. B. Alright, right here. It says measurement of G8. So we want to find this. Now, do you guys see how this is a diameter? A diameter is half a circle, right? It has an arc of half a circle, which is 180. So if I just denote this as x, basically 62 plus x is going to equal to 180 degrees. Subtract 62 from both sides, x is equal to 118 degrees. Now we're going to get into more interesting stuff. So we gotta solve for x. So both of these are central angles, so that means they're equal to the arc length, or sorry, not the arc length, the measure of the arc. And then remember, a whole entire circle is equal to 360. So 149 plus 9x minus 5 plus 11x plus 16 is all equal to 360 degrees. And then let's simplify. So 149 minus 5 equals plus 16 is going to give us 160. And then combine like terms, so the 9x and the 11x, combine those, so we're going to get plus 20x is equal to 360. Isolate x, so let's subtract 160 from both sides first. Divide both sides by 20. X is going to equal to 100. And, my bad, 10. That's B. Okay. For question 50, you guys. Oh, so we just gotta find the value of x. So remember, a circle is 360 degrees, so 66 plus 135 plus 30x plus 9. I am running out of room, so all of this is equal to 360. So we can combine 66, 135, and 9, you guys, and that is going to combine to be 210 plus 30x is equal to 360. Let's isolate the x, so let's subtract 210 from both sides, moving it over here. 30x is going to equal to 150, divide both sides by 30, x is equal to 5, C. Okay, so 51, this is where you guys were going to get into inscribed angles, okay? So do you guys see this right here? So this angle right there, you guys, is what you guys call an inscribed angle. And you guys know that, I want to make this smaller a bit. So this is an inscribed angle. So remember, the inscribed angle is half of the arc, of the intercepted arc. So it's half of this arc right here. It's half of that blue. So basically, if it's half the blue, that just means that the blue is just double of that. So the blue is really 104 times 2 for 208. So if the whole entire blue arc is 208, then we just need to solve for this x. Well, 84 plus x is equal to that blue arc, which is 208. Subtract 84 from both sides. X is going to equal to 124 degrees. Okay. Now, if you guys try number 52, so this is another inscribed angle right there. So the inscribed angle is half of the arc. So this arc right here, which is in blue, so the inscribed angle is half of that, which also means that blue arc is double of that angle 40. So that means this is 80. So we need to solve for that. So basically, right, our circle is 360. So 360 is equal to 120 plus 80 plus x. 360 is equal to 200 plus x. Subtract 200 from both sides, and you guys are going to get 160 is equal to x for C. So you guys are going to have to know your inscribed angles for sure, and then remember it's half of the arc, or the arc is double the inscribed angle. Alright, so these ones, you guys, are using your knowledge of major arcs and minor arcs. So it's one, I'll write it in black and then I'll just highlight this stuff. Okay, so 1/2 major arc minus the minor arc is equal to the angle. So I'm just gonna highlight for us. All the major ones will be in blue, and all the minor ones will be in red. So for 53, you guys, here's the major arc, which is right there. And we're gonna be subtracting the minor arc. And that canceled out, which is never really good. Alright, hold on one sec. Let's get it back up. There we go. Punch it in. 8419. Alright, we are back on. Alright, so remember that blue is the major, and this one's the minor arc. And I'll just denote the green. The green is our angle. So that's our angle. Okay, so follow the formula, right? So 1/2 major, we don't know what it is, we'll just denote it as x. X minus the minor, which is 82, is equal to the angle, which is 39 degrees. Now, instead of distributing this 1/2 to both of these, you guys, let's just multiply both sides by 2 so we can cancel off the fraction. So x minus 82 is equal to 39 times 2, which is 78. Add 82 to both sides. X is going to equal to 160 degrees, D. Okay, this one over here, here's the angle, which is what we're solving for. Here is the minor, and here is the major. Okay, so now we don't know what the major is, but remember that minor arc and the major arc for these types of circles is equal to 360. So 360 minus 115, you guys, is 245. So this blue is 245 degrees. Now we can use our formula. 1/2 major arc, which is 245, minus 115 is equal to the angle. So 1/2, look at the parentheses, right? 245 minus 115, you guys, is 130, which is equal to the angle measurement. Half of 130, you guys, is 65 degrees. So it's D. Okay, 55, here's, here's the major arc for these types of problems, right? Here's your guys' minor arc, and here's your guys' angle measurement. Okay, so 1/2, using the formula, right? Major arc, which is we don't know, so we'll just denote that as x, minus the minor arc, which is 65, is equal to the angle measurement. To get rid of this fraction, I'm just going to multiply both sides by 2. This cancels, so x minus 65 is equal to 60. Add 65 to both sides, x is going to equal to 135 degrees. Whoops, 125. So that's A. Alright, last but not least, we got the 56. Okay, so for these types of problems, you guys, when you got a tangent with a line, basically this arc right here is half of that angle, or that angle, or sorry, this arc is double that angle, or this angle is half of that arc. So since the angle's right there, we're given the angle, so just multiply by 2 to get the arc. So 54 times 2, you guys, is just 108 degrees. Alright, last 4. So this is you guys just simplifying your square roots. So 3 square root of 16. Since it's a square root, right, gotta find your pairs. So 4 and 4, 2 and 2, 2 and 2. Here's one pair, here's one pair. Remember, the pairs get to come on the outside of the square root. So 3 times 2, the 2 is from the first pair, and this other 2 is from the other. No leftovers, so there's no more square root. 3 times 2 times 2 is 12. So D. You guys could also have recognized that the square root of 16 is 4, so it would just been 3 times 4, which is 12. Alright, over here, 3 square root of 18. So 18 is 9 and 2, 3 and 3. I found a pair of 3s, so that means the 3 get to come on the outside. So this 3, which was already there, times the 3 because of the pair, square root of 2, because that's the leftover, right? 3 times 3, you guys, is 9 radical 2. Over here, 3 square root of 12, factors 4 and 3, 2 and 2. We found a pair, so that means the pair gets to come on the outside of the square root, so the 3, which is already there, times the 2, which is the pair, square root of the leftover, which was that 3. 3 times 2, 6, square root 3. And lastly, this one's 3 square root of 54, 9 and 6, 3 and 3, 3 and 2. Only found one pair of 3s, so 3, which was originally on the outside, the pair of 3s come on the outside, square root of the leftovers. Both of these are the leftovers, so 3 times 2. So 3 times 3 is 9, 3 times 2, 9, square root 6. So, there is going to be some questions on the final, you guys, which are kind of different from this stuff, but it's not out of the realm of possibility on what you guys can achieve. So, study up this final, you guys. This should be a very useful way to study, and there will be some bonus questions on your guys' stuff. Alright, good luck everyone, and yeah, peace.